How can I use the apply function for a single column? I have a pandas data frame with 2 columns. I need to change the values of the first column without affecting the second one and get back the whole data frame with just first column values changed. How can I do that using apply in pandas?
Given a sample dataframe DFS, what you want is that returns for a single column. Better to use map like this.
Given the following data frame df and the function complex underscore function. There are several solutions to use apply on only one column. In the following I will explain them in detail. Simple solution. The straightforward solution is the one from at Fabio Lamina. Output. Only the first column is modified, the second column is unchanged. The solution is beautiful. It is just one line of code and it reads almost like English. Take call 1 and apply the function complex underscore function to it. However, if you need data from another column, for example call 2, it won't work. If you want to pass the values of call 2 to variable y of the complex underscore function, you need something else. 2. Solution using the whole data frame. Alternatively, you could use the whole data frame as described in this so post or this one. Or if you prefer, like me, a solution without a lambda function. There is a lot going on in this solution that needs to be explained. The apply function works on pd.series and pd.dataframe. But you cannot use df call 1 equals df.apply complex underscore function dot log column call 1 because it would throw a value error. Hence, you need to give the information which column to use. To complicate things, the apply function does only accept callables. To solve this, you need to define a lambda function with the column x call 1 as argument, i.e. we wrap the column information in another function. Unfortunately, the default value of the axis parameter is 0, axis equals 0, which means it will try executing column-wise and not row-wise. This wasn't a problem in the first solution, because we gave apply a pd.series. But now the input is a data frame and we must be explicit, axis equals 1. I marvel how often I forget this. Whether you prefer the version with the lambda function or without is subjective. In my opinion, the line of code is complicated enough to read even without a lambda function thrown in. You only need the lambda function as a wrapper. It is just boilerplate code. A reader should not be bothered with it. Now, you can modify this solution easily to take the second column into account. Output. At index 4 the value has changed from 1 to 2, because the first condition 7 is greater than 5 is true but the second condition 7 is greater than 8 is false. Note that you only needed to change the first line of code, i.e. the function, and not the second line. Side note: never put the column information into your function. By doing this, you make a general function dependent on a column name. This is a bad idea, because the next time you want to use this function, you cannot. Worse, maybe you rename a column in a different data frame just to make it work with your existing function. Been there, done that. It is a slippery slope. (3) Alternative solutions without using apply. Although the OP specifically asked for a solution with apply, alternative solutions were suggested. For example, the answer of George Petrov suggested to use map, the answer of Thibaut Duvernay proposed assign. I fully agree that apply is seldom the best solution, because apply is not vectorized. It is an element-wise operation with expensive function calling and overhead from pd.series. One reason to use apply is that you want to use an existing function and performance is not an issue. Or your function is so complex that no vectorized version exists. Another reason to use apply is in combination with groupie. Please note that dataframe.apply and groupie.apply are different functions. So it does make sense to consider some alternatives. Map only works on pd.series, but accepts dict and pd.series as input. Using map with a function is almost interchangeable with using apply. It can be faster than apply. See this SO post for more details. Apply map is almost identical for data frames. It does not support pd.series and it will always return a data frame. However, it can be faster. The documentation states, in the current implementation apply map calls func twice on the first column/row to decide whether it can take a fast or slow code path. But if performance really counts, you should seek an alternative route. Assign is not a feasible replacement for apply. It has a similar behavior in only the most basic use cases. It does not work with a complex underscore function. You still need apply, as you can see in the example below. The main use case for assign is method chaining, because it gives back the data frame without changing the original data frame. Annex: how to speed up apply. I only mention it here because it was suggested by other answers, for example at Durjoy. The list is not exhaustive. Do not use apply. This is no joke. For most numeric operations, a vectorized method exists in pandas. If/else blocks can often be refactored with a combination of Boolean indexing and .lock. My example complex underscore function could be refactored in this way. Refactor to Python. If you have a complex equation and the parameters of the equation are in your data frame, this might be a good idea. Check out the official Pandas user guide for more information. Use raw equals true parameter. Theoretically, this should improve the performance of apply if you are just applying a numpy reduction function, because the overhead of pd.series is removed. Of course, your function has to accept an array. You have to refactor your function to numpy. By doing this, you will have a huge performance boost. Use third-party packages. The first thing you should try is Numba. I do not know Swifter mentioned by it Durjoy, and probably many other packages are worth mentioning here. Try/fail/repeat. As mentioned above, map and apply map can be faster, depending on the use case. Just time the different versions and choose the fastest. This approach is the most tedious one with the least performance increase.
You don't need a function at all. You can work on a whole column directly. Example data. Half all the values in column A